Hello friends, welcome back to Medico Srinjoy. Today our topic is enamel and amelogenesis. The first part is enamel. So let's start with the enamel. Enamel is the hardest structure in the human body. The hardness order is highest in the enamel, followed by dentin, and finally the least is the bone. Now, the thickness of enamel is about 2 to 2.5 millimeter. Also, its specific gravity is about 2.8 and the refractive index of enamel is 1.62. Friends, we also need to note that the enamel is semi-permeable. Also, the translucency of the teeth is directly proportional to the calcification of enamel. Now moving on to the next part, the chemical properties of enamel. Friends, it's a very important topic as per the Viva question. The most common question comes in Viva are what is the inorganic substance present in the enamel and its percentage. So we need to know that the inorganic portion present in the enamel is the hydroxyapatite crystals. So it's a hydroxyapatite crystals and it is present in 96%. So majority, that means almost 96% of the enamel is made up of hydroxyapatite crystals. It's a very important question. Now let's move to the next part, that is the organic portion. So the inorganic portion is hydroxyapatite crystals with 96% and the organic portion. The organic portion is 3% water and 1% organic matter. Okay, that is the organic portion is 3% water and 1% organic matter. This organic 1% is further divided into amelogenesis and non-amelogenesis, where these amelogenesis are 90% and the non-amelogenesis are only 10%. We also need to know that the amelogenesis have low molecular weight while the non-amelogenesis have high molecular weight. Some non-amelogenesis examples are enamelin and ameloblastin. Now further moving on to the enamel rods. So we need to know that what are enamel rods. The enamel is made up of enamel rods. So the whole enamel is made up of enamel rods. There are about 5 to 12 million enamel rods present in the teeth, 5 in the small incisors, and while the 12 millions are in molars. These enamel rods follow a wavy course and there is a very important structure present in it which is called Hunter-Sugar band. So let's study first about the Hunter-Sugar bands. What are these Hunter-Sugar bands? These are nothing but the optical phenomenon. It's an optical phenomenon produced due to the changes in the direction of the enamel. This forms alternating dark and white bands like structures, which are called parazones and diazones respectively. It's very important to know that the dark alternating structure is called the parazone while the light is the diazone. It's a very confusing. So we need to understand that the dark is parazone and the light is diazones. Due to the directional changes in the enamel rods, these phenomena occur. Now, moving on to the next part, we have incremental lines of Retzius, or we also call it as stripe of Retzius. So, what is this? It is a brown band. So, it's a brown band of incremental pattern of enamel. So, it's a brown band which shows the incremental pattern of enamel. That means, in simple word, this is a successive apposition of layers of enamel during formation of enamel. So it is a successive apposition. So the enamel are formed in layers. We know that the enamels are formed in layers. So these incremental lines of edges show the lines which shows the layered structure of enamel. Now moving on to the next part, we have the next topic, that is gnarled enamel. So what is gnarled enamel? It's a very important question as per the Viva, that what is a gnarled enamel. Gnarled enamel is nothing, so it is nothing but an optical appearance. So we need to know that enamel rod is an optical phenomenon, but gnarled enamel is an optical appearance due to the alternating clockwise and anti-clockwise deviation of the rods from the radial direction. It is due to the alternating clockwise and anti-clockwise deviation. So it's an optical appearance and alternating clockwise and anti-clockwise deviation from rods of radial enamel forms this. Next, we have very important topic, that is surface structures of enamel. We need to know that there are mainly 4 surface structures. These are prismless enamel, perikymata, rod ends, and cracks. Okay, there are mainly 4. Now we need to understand these 4 topics in different parts. That is, first is the prismless enamel. So what is prismless enamel? It's a structureless enamel. Okay, and this structureless enamel is hyper mineralized. We need to know that it's a hyper mineralized structure. Also, these are present in 100% of deciduous teeth and 70% of permanent teeth. So these are always present in the deciduous teeth and in 70% permanent teeth. Next, we move on to our next topic, that is perikymata. What is perikymata? Perikymata is the external manifestation of striae of Retzius. It's a very important question. That is, what is perikymata? It is the external manifestation of striae of Retzius. We have already learned striae of Retzius. Now, these perikymata are about 30 in number per millimeter in cemento-enamel junction and only 10 per millimeter in incisal region. Also, we need to note that these perikymata are continuous and parallel to each other. So these are continuous and parallel. Now moving on to the next part, we have enamel rods. So what are enamel rods? Sorry, not enamel rods, enamel ends. So what are enamel ends? Enamel ends are the ends of the enamel rods. So these are nothing but the ends of the enamel rods. Also, we need to know that the enamel rods in the occlusal or incisal region are the deepest concavity, while at the cervical region it has the shallowest concavity. I further repeat that in the shallowest at the cervical region, and it is deepest in the incisal or the occlusal region. Now we go to the last topic, that is the cracks. What are cracks? Cracks are the outer edge of lamella. So these are the outer edge of lamella. They are evenly spaced. Okay, they are evenly spaced and they are about 90 degree with the dentino-enamel junction. Now we further move on to the very important next topic, that is, what are neonatal rings or lines? Friends, this topic is very frequently asked in the Viva and MCQs. So let's understand this topic. So neonatal rings are nothing but the boundary between the prenatal and the postnatal enamel. Okay. We also need to know that perikymata, we have already learned perikymata, that is, perikymata are absent in prenatal enamel but are present in postnatal enamel. Also, prenatal enamel is better than the postnatal enamel because it is developed in the protective environment and better supply of nutrients. So you know that it's a very protective environment or better supply of nutrient makes it better. Now moving on to the next topic, we have Nasmyth membrane. So what is Nasmyth membrane? Nasmyth membrane is a primary enamel cuticle. Okay, it is a primary enamel cuticle. It covers the crown of the newly erupted teeth, but it gets lost due to the continuous mastication and other stresses. These are mainly secreted by the ameloblast and resembles like basal lamina. Now moving on to the next topic, we have enamel lamella. It's a very important topic. So what are enamel lamella? Enamel lamella are leaf-like structures. Okay, this extends from the enamel towards the dentino-enamel junction. It develops in the plane of tension. Okay, it develops in the plane of tension. Also, it consists of organic matter, but it has very little mineral content. Okay, now moving on to the next topic, that is, what are enamel tufts. Okay, what are enamel tufts? Enamel tufts resembles grass in the ground section. Okay, they resembles grass like structure in the ground section. Okay, it consists of hypocalcified enamel rods. So it's very important. We already learned that the prismless enamel are hypermineralized, but these enamel tufts are hypomineralized. Now we move on to the next topic, that is, what are dentino-enamel junction? Dentino-enamel junctions are the scalloped line structures which are convex towards dentin. This line is very important, friends. That is, the dentino-enamel junction scalloped lines. Okay, but this scallopedness is convex towards dentin. Also, the scalloped is scalloped more in the occlusal portion. Why? Why it is more there? Because scalloping is more seen in the occlusal portion because of the masticatory stress are high in occlusion portion. Also, dentin enamel junction has preformed even before the development of hard tissue. Now, moving on to the next part, we have enamel spindles. Also, enamel spindles are also hypocalcified structures. Okay, they are hypocalcified structures and they mainly originates from the odontoblastic process. So, you friends are know what are odontoblastic process? You know, this odontoblastic process we will learn in the dentin. That is, we will learn in this next video. These enamel spindles are mainly found in the cusp region of teeth. Now, moving on to the clinical aspects. What are the clinical aspects of enamel? First, there are mainly three clinical aspects. That is, what is cavity preparation? This cavity preparation may cause microleakage. Okay. Next, we have deep enamel fissures. These deep enamel fissures may cause decay. While the enamel lamella, this enamel lamella may initiate caries. Okay. This enamel lamella may initiate caries. Now, moving on to our next topic, it's a very complicated topic, but these are not frequently asked in exam. So, there are I made this in the PDF notes. If you like, you can download it from the description box. That is the life cycle of ameloblast. Friends, you can download it from the PDF notes in the description box. You like the video and subscribe my channel. So moving on, we have life cycle of ameloblast. There are mainly 6 stages: morphogenic, organizing, formative, maturative, protective and desmolytic. Download the PDF in the description box to get the detailed information. Okay, so let's move to the next topic and our last main topic, that is, what is amelogenesis? What is amelogenesis? Amelogenesis is the process of formation of enamel. Okay, it is the process of formation of enamel. This amelogenesis occurs in mainly 3 steps. That is, first is the organic matrix formation, second is the development of Tome's process, and third is the mineralization and maturation. We will now study each topic in details. That is, our first subtopic here is the formation of the organic matrix of enamel. That is, formation of organic matrix of enamel. First, we have what is reciprocal induction. Okay, what is reciprocal induction? This is a very important question for Viva. That is, ameloblast starts enamel formation. Ameloblast starts enamel formation even before, only when it starts enamel formation only when a layer of dentin is already laid down. So this process is called reciprocal induction. Okay, now we have many matrix protein, that is enamel matrix protein, like amelogenesis, enamelin, ameloblastin, tuftelin. This all enamel matrix protein helps in the formation. For example, tuftelin helps in cell signaling, ameloblastin and enamelin helps in the nucleation and growth of enamel crystals, while amelogenesis maintain the distance between the enamel crystals. Now, moving on to our next subtopic, that is developments of Tome's process. Development of Tome's process. So first we need to understand what are Tome's process. Tome's process are the pyramidal cytoplasmic extension at the distal part of each ameloblast. Okay, enamel secretion occurs from this at 2 sides of Tome's process. These are at the proximal end and the distal end. Okay, at the proximal end, so you need to remember that at the proximal end it forms interrod enamel. Okay, at the proximal end it forms interrod enamel, while in the distal end it forms enamel rods. Okay, when the first layer of enamel is laid down, Tome's process consists only of proximal portion, and hence initial enamel are rodless. So initial enamel are rodless. Next on, moving to our last subtopic in today's lecture, that is mineralization and maturation of enamel matrix. This mineralization and maturation occurs in 2 parts. That is, first is the Immediate partial mineralization. So what is that? In immediate partial mineralization, one octacalcium phosphate crystals give rise to two hydroxyapatite crystals. Okay, one octacalcium phosphate give rise to two hydroxyapatite crystals. And last we have maturation. So maturation is characterized by the gradual completion of the mineralization starting from the height of the crown and progresses cervically. Okay, you need to know that it starts at the crown and progresses cervically. Also, these crystals which are formed increases further after tooth eruption. Because why? Because of the ion exchange with saliva. These crystals further increase. So this is the end of the enamel and amelogenesis. Hope you like my video, and if you have any queries, please comment and I will try to answer your comments. So if you like my video, like, share and subscribe. Medico Srinjoy. Next we have videos of dentine and dentinogenesis. So if you like my channel, subscribe it to get notification of all the upcoming videos, and next day we will study dentine and dentinogenesis. So thank you guys, keep supporting.